trapezoids, out of all the shapes that we've done, is definitely the hardest and most complicated one. Okay, so let's first talk about what a trapezoid looks like, because if you can't identify a trapezoid, you're not going to be able to do the correct formula. Okay, so when we look at a trapezoid, here is a picture of a trapezoid. There are different ways trapezoids can look, and I will give you guys some different examples so that way you see them all. Okay, but if we look here, we have what's called a base with this little 1 below it. It's called a subscript 1. That means base 1. Then the next one is base with a subscript of 2. That means base 2, which means there's how many bases, you guys? 2. We have a 1 base and a second base, and then we have the height, okay? And then we'll talk more specifically about what that height means. So, what do we know base is? Just base in general. What's base, Eba? Okay, top and bottom. Okay, so base 1 and base 2. Base 1 is the top base on a trapezoid. And base 2 is the bottom on a trapezoid. So with trapezoids, there are 2 bases, a top base and a bottom base. These bases, guys, are what we call interchangeable. Meaning, I could make the bottom be base 1 and the top be base 2, and I will still get the same answer. Is that understood? Okay? No matter what, as long as your bases, you're using them the same. So when I look at this one, this is my base 1 because it is my top base, and the bottom is my base 2 because it is the bottom. One thing I want you guys to write down is your bases are always parallel. Parallel. That's not right. I think it's 2 L's. So the bases are always parallel, meaning, anyone know what the word parallel means? The lines will never cross. The lines will never intersect. The lines will never touch. So these lines, top and bottom, if they were to go on forever and ever and ever, do you see how they're never ever going to touch? They're never ever going to cross because they're perfectly straight. Does that make sense? I could turn my notebook sideways and they're still never ever going to touch, are they? So this time the base is not these 2 because those sides would touch, wouldn't they? So it's always the 2 sides that will never ever touch, whether they're going up and down or whether they're going side to side. Is that understood, guys? Okay. Then the height. What do we know the height is, you guys? The distance So this time it's the distance from what to what? From base 1 to base 2. So it's the difference between, or the distance between, our base 1 and our base 2. So we've kind of already talked about this. The height of a trapezoid is measured by drawing a straight line from B1, from base 1, to B2, base 2, intersecting that'd be able to spell right, intersecting each at a 90-degree angle, which we've been talking about this entire time. So your height is whatever line goes from the top of the base to the bottom of the base at a 90-degree angle. If it is not at a 90-degree angle, it is not the height. Is that clear? So what's my height, guys? Your dotted line is your height. It could be one of these if they were at a 90-degree angle. Has to be at a 90-degree angle, and then it can be the height. Yes. Yep. Yeah, absolutely. Yes, yes. What do we call these two right here? Those are our sides. Okay. So if we look down below to start being able to calculate it, okay, the formula for a trapezoid is this right here. However, that is not the formula that's given on your InSCAS sheet. So I want everyone to flip back to their InSCAS sheet, which was that like lime green piece of paper. Find where it says trapezoid. And that's actually the formula that we need to use because that's the one that I need you guys to get used to because that's the one that's on the InSCAS reference sheet, not the other one. Okay, so this is the one that you guys will be able to use. So right here it says area equals 1/2 h, which is height, and then inside parentheses B1 plus B2. So we are going to write that down on our trapezoid page. So we're going to go back over here. And we are actually going to write down area equals 1/2 h. And then I'm going to put parentheses B1 plus B2. Both of these guys will get you the same answer. But this is the one that they will always give to you, and you don't have to have it memorized. So that's why we got to get used to that one. Okay, so let's try it. If you do not have it on your calculator, get out your calculator for me, please. Thank you. Okay, are we ready? Okay, so first things first, we are going to write down our formula. A equals 1/2 h, parentheses, B1 plus B2. That's the first thing I want you to do on every single problem. Because the more you write the formula, the more you're going to memorize it, and the less you'll have to look at that InSCAS sheet because it will be memorized, which is a good thing. The sheet's there to help you, but the more you have memorized, the easier it gets. So then your first step is to plug in all of the numbers. Okay, so I have 1/2 times my h. What does h stand for, everyone? Height. Which number is my height? 10. So I'm going to plug in a 10. Then I'm going to have that times whatever is inside parentheses. And my parentheses are my B1 and my B2. What's my base 1? 8. What's my base 2? And I'm going to write, so 8 plus 16, and then close that parentheses. Now I need to solve it with order of operations. So what must I do first? 8 plus 16. You must do whatever's inside parentheses first. So you guys can use your calculator, do it in your head, do it on paper, whatever you need to do. But what is 8 plus 16? So now I have 1/2 times 10 times 24. What does that look like now? What did we do yesterday? This is your triangle formula right here. All you did with the trapezoid was add the two bases together to make one base like a triangle. So now you have your triangle formula. You can do this however you want. Finish it for me. Okay, I don't care, remember, what order you do your multiplying in, dividing in, you do whatever you want. Okay, I'm going to do it a way that I know that I can easily do it in my head. Okay, I'm going to take half of 24. What's half of 24, guys? So then I have 10 times 12, which I can do in my head. And what's 10 times 12? So I didn't need a calculator, but you guys are more than welcome to use it. 120 what? Very good. Now, can I find perimeter on this problem? Yes, this one you can, because these two lines, because I've got 11 right here, right? 8 right here, it was kind of hidden. 11 here, and 16 here. How do we find perimeter, you guys? Everyone do that for me, please, and thank you. Show your work. Remember, you can use your calculator, but tell me what you do in that calculator to get your answer. What did we get, you guys? What did we get? 46? Very good. Questions so far? Okay. Can I find perimeter of the second trapezoid? Everyone find the perimeter for me. Go. What did we do, you guys? Added up all the sides. What are my sides? Why did we not use 18? Good, that's the height. It's not the outside. The height can be on the outside of a trapezoid, but remember it has to be at what degree angle? 90. So what did we get when we added all those sides together? 95? 95 what? Okay, let's go and find our area. So remember, write down the formula. Area equals 1/2 H parentheses B1 plus B2. Write it down. Get in that habit. Plug in your numbers. Don't do anything until you've plugged in all of your numbers. So it's 1/2 times the height. What's my height, you guys? So plug in the height. Then plug in your two bases inside parentheses. What are my two bases? Does it matter the order in which I write those bases? No. So we write 30 plus 25. The order does not matter because order of operations, what do I do first? I'm going to add inside those parentheses. So 30 plus 25, you guys. Finish the problem for me, guys. Whatever order you would like to do it in, use your calculator. Finish solving it for me. Okay, I don't want to know the answer right now because I want everyone to solve it. Did you show all your work on your paper? Thank you. What did we get as my answer? 495 what? Because what's half of 18? Half of 18 is 9. And 9 times 55 will give you that 495 meters squared. Questions?